Hi everyone. Today we're going to talk about dilations and transformations. So as we go through this foldable, I need you to remember that you need to copy down everything, and at the end of this video, your foldable needs to look exactly like mine. So if you need to pause, please pause the video. So now we're going to go ahead and we're going to start with our first transformation, which is a dilation. And a good way to start with the dilation is to talk about the definition. And it says the figure is blank or blank with respect to a fixed point. And if we think back to dilations, that's when a shape gets bigger or smaller. So it's when the figure enlarges or reduces with respect to a fixed point. And in 8th grade math, our fixed point is the origin. All right. And then the next part, it says algebraic representation. And I know that sounds a little intimidating, but we also call that the rule. And when we have any transformation or dilation, our rule is always going to start x comma y, and then they're going to turn into something. And that tells me that my coordinates change. And now we're going to say our rule looks like kx, ky. And we need to remember that k is our scale factor, okay? And that is going to be a number. So I'm going to turn my foldable out to the side this way, and we're going to write that down so we don't forget. K equals scale factor. And then another thing, to find our scale factor, we're going to take our new coordinate and we're going to divide it by our old coordinate. And one more helpful tip is that when it enlarges, that means my scale factor is greater than 1. And when it reduces, that's when my scale factor is less than 1. Just knowing that is going to help me because when I look at my rule, that's going to tell me if my shape should be getting bigger or if it should be getting smaller. So now let's read this example. Graph and label the pre-image, then draw and label the image after a scale factor of 2. And then it shows me my algebraic representation or my rule. It says xy turns into 2x, 2y. So just looking at this rule and knowing that it says scale factor of 2, I can see 2 is greater than 1. So my new shape will be an enlargement. So I need to make sure my new shape, my prime, is going to be bigger. So to start, I'm going to plot MATH. So M is at -3, 2, 1, 2, 3, 1, 2. A is at -2, 1, 2, 1, 2, 3. T is at -1, 2, 1, 2. So M, A, T, and then H is at -2, 1, 2, 1. And then I can go ahead and connect those dots. So now to get my new shape, to get my enlargement, I'm going to take that 2 and it's touching that x coordinate. That means it's multiplying to the x coordinate. So dilation means multiplication. And to remember that on the front here, I'm going to put dilation and I'm going to put multiplication. Dilation means multiplication. So to get my new coordinates or my primes, That's when I put the little apostrophe there. I'm going to do 2 times negative 3. 2 times negative 3 is going to give me a negative 6. And then I'm going to do 2 times my y, or 2 times positive 2, which will be 4. So for a prime, I'm going to do 2 times negative 2, and I'm going to get negative 4. And then 3 times 2 is going to give me 6. So my t prime will be 2 times negative 1, or negative 2. And then 2 times 2, which will give me 4. And then I need h prime. And I have 2 times negative 2, which will give me negative 4. And then 2 times 1, which gives me 2. So now that I have my new coordinates, I'm going to go ahead and graph my prime, or my new shape. So negative 6, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That'll be my M. A is at negative 4. 1, 2, 3, 4. Negative 6. 1, 2, 3, 4, 5, 6. And these are my primes, so when we label them, don't forget to put that apostrophe there. That tells me that's my new shape. T is at negative 2, 4. 1, 2, 1, 2, 3, 4. T prime. And then H is at negative 4, 2. 1, 2, 3, 4. 1, 2. So before we started this example, we did say that it was going to be an enlargement. And we can tell that going from the original, my black diamond, to my prime, my new orange diamond, my shape did get bigger. Now, to make sure we understand how to find the scale factor, if we have the coordinates, we're going to do new over old. So K equals new over old. So I'm going to pick a coordinate in either the X or the Y, and we're going to do this fraction and see if it works. So I'm just going to pick M because it's the first one. And I'm going to pick my Y's because they're both positive. So K equals, my new coordinate for M prime is 4 over my old, which was 2. And when I do 4 divided by 2, I get 2. So I can see that I did it correctly, and now I can find the scale factor if I need to. Make sure yours looks like mine. Pause if you need to, and we're going to move on to a reflection. Okay. And on this front, we're going to go ahead and circle that FL, because we need to remember that a reflection is when we flip the shape. Most of you remember what a reflection is by looking in the mirror. So we're going to start with our definition. It says the figure is flipped over a line. And in 8th grade math, there's only 2 lines that we flip over. We flip over the x-axis or the y-axis. So again, we need to write our algebraic representation. And I'm going to write rule there because I need to remember I can interchange those words. And like I said, there's 2 lines we could reflect over. So I'm going to write both of the rules. I'm going to write the rule for a reflection across the x-axis. And then I'm going to write the rule for a reflection across the y-axis. And just like our dilation, our rule is going to start x, comma, y with our arrow. Now I want you to think about a reflection, and when you look in the mirror, you're backwards. Okay, so a way to remember a reflection rule is that if we are going to flip over the x-axis, we're going to change the y-coordinate. We're going to do the opposite. So I'm going to leave my x there, but I have a positive y here, and I'm going to change it by doing the opposite. So my rule would be a negative y. So then when I do a reflection over the y-axis, my rule will start the same, xy turns into, and again, I'm going to do the opposite. So instead of changing my y-coordinate, I'll change my x-coordinate. And I have a positive x, so I would change it to a negative x. Now, if I have a negative coordinate, I'm going to do the opposite, so it would become positive. If my coordinate is positive, then it would become negative. So let's go ahead and do this example. It says graph and label the pre-image, then reflect the image over the x-axis, labeling all image points. So over the x-axis, and it gives me my rule, x comma y turns into x negative y. So before I start messing with the rule, I'm going to go ahead and graph my image. So -2, 4, 1, 2, 3, 4. -1, 5. And 2, 1, 2, 5. 1, 2, 3, 4, 5. So this was A, B, and C, and that will make a triangle. So to reflect this shape and to get my prime or my new figure, if I look at my rule here, my x's, positive x, stayed positive x. My y was positive, but it turned into a negative. So I'm going to change my y's. I'm going to do the opposite of those y coordinates. So I'm going to circle the y coordinates because those are the ones I'm going to be changing. So I have a prime. I'm going to write down my x the same, so -2. And then I'm going to do the opposite of my y. So I have a +4, and the opposite of +4 is -4. For my b prime, I have -1, that's going to stay the same. And I have a +5, so when I do the opposite, that's going to give me a -5. And then C prime, I'm going to keep my 2, and that +5 will turn into a -5. So then I can graph it. So my A prime is going to be at -2, -4, 1, 2, 3, 4. B prime is going to be at -1, -5. And C prime will be at 2, 5. And when I connect the dots, I have a reflection across my x-axis. And here's my x-axis. So if my mirror was there on the x-axis, it flipped it to the other side. And I do want to talk about the shape. So if I look at my dilation, my shape either got bigger or smaller. But when I look at my reflection, my shape stayed the same. It just flipped. So on the front, we're going to make this little note. Dilation, we're going to put not congruent. Okay. So then on reflection, we're going to write congruent. Because remember, congruent means same size, same shape. In a dilation, they're the same shape, but they don't stay the same size after my transformation. On my reflection, they do stay, it is the exact same shape and the exact same size. So next we can move on to a translation. And on our reflection, we circled the FL to remind us that we're going to flip the shape. So on a translation, we're going to circle the SL, and that's going to remind us that a translation is when we slide the shape. So let's get started on this one. And we are going to start here with the definition and the rule. So it says each point of a figure is moved the same distance and in the same direction. All right. So what I need you to do is we're going to make a little coordinate plane, and we're going to label our x-axis and our y-axis. And then we're going to make this note that on our x-axis, when we go to the right, those numbers are positive, so we're going to put a plus sign there. On our x-axis, when we go to the left, those numbers are negative, so we're going to put a negative sign. And then we're going to talk about the y-axis. So when we go up, those are positive numbers. And when we go down, these are negative numbers. All right, so the reason we did that is because our algebraic representation, or our rule for translations, are going to start the same. That's right, rule to remind us. But it's going to start x comma y with an arrow. But because we're moving directions here, we're going to have our x coordinate, and we're either going to add or subtract depending on if we go left or right. So we're just going to put a plus sign, and then we're going to use the letter A as a number. And then our y, we're going to put a plus sign, and then we're going to use the letter B. And these are telling us whether we're going up or down. So we could have negative signs instead of the plus sign there. I know that might sound confusing, so let's go through this first example, or this example. Graph and label the pre-image, then find the image points using the given rule. Draw and label the image. Okay, so we're going to start by just labeling our rule. So A is at negative 2, 3. 1, 2, 1, 2, 3. B is at negative 1, 6. And C is at 1, 3. 1, 1, 2, 3. We're going to label and connect the dots. And on this problem, it gave us the rule. So now we are going to read it. And it says x plus 5. So I'm going to come down to my x-axis, and I see plus, and that's to the right. So this tells me I'm going to go to the right 5. And then it says y minus 3. So I go to my y-axis, and it says minus, so that's down. So I'm going to go down 3. And our definition says each point is moved the same distance and in the same direction. So I'm going to go from A, I'm going to go right 3, down 3, right 5, down 3 from each point to get my prime. So 1, 2, 3, 4, 5. 1, 2, 3. That's where my A prime is going to be. B prime would be 1, 2, 3, 4, 5. 1, 2, 3. And C prime, 1, 2, 3, 4, 5. 1, 2, 3. And now I have my new coordinates. So A prime is at 1, 2, 3, 0. B prime is at 1, 2, 3, 4, 1, 2, 3. And C prime is at 1, 2, 3, 4, 5, 6, 0. Now, if you forgot where it says like how to read this rule to say write 5 down 3, we could plug in and do the math. So I could do -2 plus 5, and that would give me 3. And then I could do 3 minus 3, and that would give me 0. So if we need to do the math, we can. We'll get the exact same coordinates. Now, on the front of these two, we said dilations were not congruent. Reflections are congruent. So let's look at our triangle, and I can see that this bottom line is 1, 2, 3 units long, and over here it's still 1, 2, 3 units long. So my translations are also congruent. Okay. And then for our last rotation, or our last transformation, is a rotation. And we can, but we don't have to, circle that T, and that tells me that our figure is going to turn. Okay. So let's go ahead and start with our definition. And that is when the figure is turned about a fixed point. And in 8th grade math, our fixed point is the origin. Now for our rule, or our algebraic representation, we actually have 3 rules for a rotation. Because if we have a coordinate plane, we can see that the bolded black lines, or the x and y axis, make 4 90-degree angles. So we can rotate our figure 90 degrees, that would be 1 turn. Or if I did 2 turns, that would be 90 plus 90, or 180 degrees. Or I could go 3 turns, 1, 2, 3, which would be 90 plus 90 plus 90, or 270 degrees. And then we could go 4 turns, 1, 2, 3, 4, which would give me a 360-degree rotation. So for these rules, we are going to go ahead and write down the rule for 2 kinds. We can have a clockwise rotation, or we can have a counterclockwise rotation. So to help me out, I'm going to draw a little clock here. And I know that 12 is at the top, 3, 6, 9. So if I go clockwise, that means I'm going in the directions that the hands move on the clock. And if I go counterclockwise, then I'm going backwards. Okay. Now, if I went ahead and drew a coordinate plane through my clock, if I start here at the 12 and I go 90 degrees, I would end up at the 3 if I went in the clockwise direction. So I'm going to write down for my rule 90 degrees clockwise. But I could also get to this 3 if I went counterclockwise, and that would be 1, 2, 3 turns. Okay, and 3 times 90, because that would be 3 90-degree turns, would give me 270 degrees, counterclockwise. All right. And my rule for that would be x comma y turns into, and on a rotation on the 90-degree clockwise and the 270 counterclockwise, we're going to switch the order of the coordinate. The y will come first and the x is going to be the opposite. Okay. So going back to my handy dandy clock, another rotation I can have would be if I start at the 12 and want to end at the 6, that's 2 turns. But I could also go in the clockwise direction, and that would be 2 turns as well. So 90 plus 90 is going to equal 180. So 180 degrees, either direction, clockwise or counterclockwise. And I'm going to get negative x, or let me fix that. It's going to be x comma y with the arrow. And then it'll be a negative x, negative y, or an opposite x, opposite y. And then again, we can have, if I start at the 12, I could go 1, 2, 3 turns and finish at the 9, or 270 degrees clockwise. And then if I went counterclockwise from the 12 to finish at the 9, that would be 1 turn, or 90 degrees counterclockwise. And that rule is going to be xy turns into, and again, we're going to flip the order, but on this one, our y will do the opposite. And then if we went ahead and did a full 360-degree rotation and start at the 12, that would be 4 turns, 1, 2, 3, 4. My coordinates would stay the same because I would end up in the exact same spot. Okay, so it says graph and label the pre-image, then rotate 90 degrees clockwise around the origin. So 90 degrees clockwise. So I'm going to go ahead and graph my first one. So A is at 2, 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. B is at 7, 2, 1, 2. So A, B, and C is at 1, 2, 1, 2. And I will go ahead and connect those dots. Now, these rules are not on your formula chart. And I understand that's a lot to memorize. So you are allowed to ask for patty paper on the STAR test. And these will help you with a rotation, okay? So 90 degrees clockwise is going to be 1 turn clockwise. So you're going to take your patty paper. You're going to trace the x-axis and the y-axis. And then you're going to trace your original shape and label the points. You have to label the points. Now, it says 90 degrees clockwise. So I'm going to turn it 1 turn in the direction of a clock, the way the hands move on the clock. So I'm going to put my pencil on the origin, and then I'm going to turn it to where my x and y axis line up again. My origin should stay there in the middle. And now I have my new coordinates up here. Okay. So A prime, my A has turned. It's now over here. This is 1, 2, 3, 4, 5, 6, 7, 1, 2 negative. So 7, negative 2. B prime is now here. That is a 1, 2, negative 1, 2, 3, 4, 5, 6, 7. And then C prime is now at 1, 2, negative 2. So if I look at my rule and I look at my coordinates, my rule says I start XY and they flip places and all my X's become the opposite. So I'm going to circle my X coordinates and then I'm going to make sure that's actually what happened when I did my patty paper rotation, okay? So switch places, 7 is going to come first. Opposite of positive 2 is negative 2. Good job. B prime, Y comes first, so 2 comes first. Opposite of positive 7 gives me negative 7. Look at us, we're doing pretty good. C prime, 2 comes first. Opposite of positive 2 is negative 2. Yes. Now I am going to go ahead and graph this since I don't have my patty paper on here. So 7, negative 2, 2, negative 7, and 2, negative 2. Okay. Now, looking back, dilations, not congruent. Reflections, congruent. Translations, congruent. So if I look at my original and my prime, I can see on these straight lines, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. They have the same amount. So for rotations, we can write congruent because they will stay the same size and the same shape. Please make sure you have all this copied down. Have a good day.